Hello friends, today's class we'll see the next chapter, Visualizing Solid Shapes. Now, before going into solid shapes, we will now see what do you mean by 2D objects. 2D objects are also called as two-dimensional figures or objects. For example, the square, rectangle, triangle, circle, all these which we draw it on a paper are called two-dimensional. Why are they called two-dimensional? Because they have only two dimensions, which is the length and the breadth. Okay, they have only two dimensions, which is the length and the breadth, and they are plane surfaces. They can be drawn on a plane surface like a paper. Now let me take an example of a three-dimensional object. Now all these are three-dimensional objects because they have a length, a breadth and a height. There are three axes, namely the x-axis, y-axis and the z-axis. Whereas in the case of a circle, square, rectangle and all which we drew it on a paper, they have two axes, namely the x-axis and the y-axis. They don't have the third axis. Hence, such figures which we have drawn here, cube, pyramid, all these come under three-dimensional shapes or 3D figures. I hope you understood this. Now let us take some example. This is what is this? This is a cylinder. I hope you get it. This is a cylinder. So this is a three-dimensional object. What is this? This is a three-dimensional object. Similarly, this is not a circle. What do we call it? This is a ball, but it is not a circle. It is a sphere. What is it? It is a sphere because when I place it on a paper, I can draw a circle around it. It has also got a three-dimensional view. Okay, so this is a circle. Now we saw this is a cuboid. What is this? Because it has got a length, a breadth and a height, isn't it? So all these three things together, this is a cuboid. Okay, so this is a three-dimensional object. Now we will see the next one, that is, when I see a three-dimensional object, what are the three views I get? For example, I have taken this three-dimensional object, solid made up of three cubes. How does it look from the side? It looks like this because this side, isn't it? So it looks, this is the side view. From front, I am able to see these three squares. So that is the front view, and this is the top view. I hope you get it. So any three-dimensional object has got a three-dimensional view. For example, let me take this box. Okay, from the top it looks like this, from the side it looks like this, and the bottom it looks like this. I hope you get it. Okay. Now we will see what do you mean by faces, edges and vertices. So what do you mean by a face? This flat surface which I see here, this flat surface is called the face. Now let me take a three-dimensional object, say this box over here. Now this is the face of the cuboid, and similarly this is one face, this is another face, this is another face and this is another face. So on the whole, how many faces does this have? This will have 6 faces. Okay, so now what is an edge? An edge is nothing but this point, isn't it? This line here. This line here denotes the edge. That is, in this case, this is the edge of this cuboid. This is the edge of this cuboid. Okay. Now this is also an edge of the cuboid. Now what do you mean by the vertices? This point where all the three lines meet. So these points are called the vertices. It is a plural of vertex. Vertex plural is a vertices. All these points are called vertices. I hope you understood how we got edges, faces and vertices. So in this cube, how many faces it has? 1 face, 2 face, 3, 4, 5, top and bottom, 6 faces, 12 edges and 8 vertices. Okay, now are these 3 dimensions, that is faces, edges and vertices, can we link them with, are they related to each other, any kind of formula? Yes, you have a formula for that, that is called as the Euler's formula. According to the formula, face plus vertices minus edges is equals to 2. Suppose you are asked to find the vertices, you are given the face to be as 5 and you are given the edges to be as 9. You have to find the vertices. How will you do it? I will have 5 minus 9 is minus 4 equals to 2, or V equals to 2 plus 4, which is equals to 6. So this is Euler's formula. I hope you understood how we should visualize three-dimensional objects. Now we'll also see one more thing. What is the difference between a pyramid and a prism? The difference between a pyramid and a prism. Now let us take a pyramid. In this case, the base is a triangle, isn't it? And how are the ends? They have a pointed end. What do they have? They have a pointed end. Whereas in the case of a prism, you have a hexagon here at the bottom and you also have a hexagon at the top. Okay, they are joined together by rectangular surfaces. This is one rectangular surface. Okay, so they are joined together by rectangular surfaces. This is a prism. Whereas in the case of this pyramid, there is a triangle here. In this end, they are all pointed. Similarly, in this pentagonal pyramid, the base is a pentagon and you have triangles on all the sides. They are joined together by triangles. So when you are joined together by triangles, they are called prisms. When they are joined together by rectangles, when you are joined together by triangles, they are called pyramids. And when you have joined together by rectangles, they are called as prisms. I hope you understood this. Thank you, friends.